Hi, I'm Maddie Eric. I want to be talking about ocean plastic pollution. To introduce this topic, I first want to go over where all this plastic came from. I read an article about the Great Pacific Garbage Patch, and it really inspired me to pick this topic because I'm very interested in sustainability. It really opened my eyes to the effects of plastic pollution and how big of a scale it's on. Essentially, the Great Pacific Garbage Patch is two western and eastern patches, and it covers an area almost twice the size of Texas. In that article, the author mentioned that there are roughly 171 trillion pieces of plastic lurking in the world's ocean, which is an insane statistic and again really shows the scale of this issue. Here's a little bit of a diagram just going over how much plastic is produced every year, where it goes, what happens. Why are plastics so dangerous? They're not just a physical threat, it's a chemical hazard. It really affects the marine and ocean life, and I kind of want to dive into the chemistry behind why it is so dangerous. So I'll be going over each of these bullet points over the course of this video. I do want to touch base on what microplastics are, as I'll be talking about them quite a bit. Microplastics are tiny little plastic fragments. They're less than 5 milliliters. They come from larger plastic debris that has been broken down. Sometimes they're also intentionally produced for commercial use. And they pose a really big threat to marine life. Next, I'm going to be going over the structure of plastics and have a molecular breakdown of the plastic polymers. So, basic structure of plastics is that plastics are made of long covalent carbon chains known as polymers. These chains are nonpolar, they're hydrophobic, they're very durable and lightweight, which is perfect for commercial use, but very dangerous for the ocean. That N integer there means that it is repeated over and over again, showing how long the chains are. Some common types of plastic are polyethylene, which is grocery bags, packaging, polypropylene, which is food containers, bottle caps, polystyrene, which is foam cups, insulation, and polyethylene terephthalate, which is the thicker drink and water bottles. This is the chemical structure of each of these plastics I went over. The N again means that it's a big repeating integer, so these are very long chains. Their durable structure and weak intermolecular forces make them very resistant to degradation, and over time they break into microplastics, which I'll be going over in the next slide. We can tie the degradation of plastics to our kinetics unit. So the rate that plastic breaks down depends on factors like temperature, UV exposure, and surface area. Um, because it is an endothermic process, it requires a big input of energy, like sunlight or heat. Sunlight or UV radiation can break down carbon, or carbon-hydrogen bonds in plastic through a process called photodegradation. This leads to reactions and the formation of oxygen-containing groups like ketones or alcohols, making the plastic fragment into microplastics. Some plastics also undergo oxidation, which is where they react with the oxygen in the air, further weakening their structure and making them brittle. There's also thermodegradation, where the heat causes chain scissions and breaks down the polymer chains, and biodegradation, which is very rare, but is where bacteria breaks down the plastics and it happens at extremely slow rates. Solubility of plastics. Why don't they dissolve? The structure of polymer chains makes plastic strong, durable, and resistant to solvents. The long chains are made of carbon and hydrogen, which are nonpolar. And as we learned in class, like dissolves like. So because water is polar and plastic is nonpolar, they don't mix or bond and therefore do not dissolve. Going forward, these polar hydrogen bonds formed in water have a very strong attraction, while plastics have dispersion forces, which are too weak to interact significantly with water. Because the forces mismatch, the water cannot pull apart the plastic molecules. Plastics, again, are long-chain macromolecules, which means they have a very large and high molecular weight, making them resistant to water as well as UV light and microorganisms. The chains are also hydrophobic and repel water. They are chemically inert, which means they don't easily react. And all these things really contribute to plastic's persistence in oceans. Next, I'll be going over chemical leaching. So what is chemical leaching? Chemical leaching is a process where chemicals embedded in plastics slowly escape into the surrounding environment, which in this case is the ocean water. These additives are not chemically bonded to the plastic polymer chain, so they can migrate out over time, especially when exposed to heat, UV light, or mechanical stress. Common chemicals that leach from plastics are BPAs, which are used in polycarbonate plastics and epoxy resins. They mimic estrogen and they're linked to hormonal disruption in wildlife and humans. Phthalates are plasticizers that make plastics like PVC more flexible. They disrupt the endocrine system, which affects the reproduction and development in animals. There's also flame retardants like PBDEs. These are added to plastics and electronics and textiles to make them flame resistant. They're bioaccumulative and neurotoxic. Heavy metals like lead and cadmium are also sometimes used in plastic pigments and stabilizers. They're toxic at low concentrations and biodegradable. Like we went over before, plastics degrade from UV radiation, oxidation, but also physical stress, like from ocean currents and ocean waves. This causes their surface layers to crack and release the embedded additives. A lot of these additives, like we went over before, are hydrophobic, but they're also lipophilic, which means that they stick to fats very well. So everything in fish tissues and organs and other marine life, which makes it very dangerous. Ocean acidification from greenhouse gases and the carbon dioxide in the air increases the temperature and lowers the pH of ocean water, which in turn accelerates the rate of bleaching. Microplastics are also particularly prone to releasing and absorbing toxic chemicals as they have such a large surface area. We've already gone over most of the environmental and biological impacts of plastics on marine life just over throughout the video. But just to summarize, the chemicals in plastics mimic hormones, which disrupts the endocrine. They damage organs and reproduction ability. They bioaccumulate in tissue and biomagnify in the food chain, which reaches us. Overall, plastic pollution threatens biodiversity, food safety, and ocean health. Coral reefs and ocean habitats are also very damaged as plastics interfere with growth and oxygen flow. This is another helpful diagram of what happens to plastic in the ocean, how it goes from bigger particles to smaller and smaller, and goes into the food chain. Moving forward, how can we help? The best way, of course, is to not use plastic. So some alternatives would be glass, stainless steel, wood, silicone, or reuse the plastic that you already have. I was also reading this really interesting article from the University of Tokyo, where a professor, Takuzo Ida, has pioneered molecular polymers, which have reversible chemical bonds, which are easy to biodegrade and don't have microplastics. He's really pushing for making molecular polymers that are only reversible in ocean water or salt water, which would be really amazing and a huge step towards progress. So how can you help? You can reduce single-use plastics, so no plastic straws, bag, cutlery, reuse things, reuse water bottles, grocery bags. Recycle properly. Learn how to recycle, learn the rules for your city, and rinse and sort recyclables. A lot of things that are supposed to be recycled aren't, so take care. Choose plastic-free products. Like I said before, there's lots of alternatives. Look for items with biodegradable and recyclable packaging. Buy in bulk and reduce packaging waste, or buy secondhand. Support bans and cleanup efforts. You can join or donate beach cleanups or plastic reduction campaigns. You also can use your vote to support for laws that ban plastic bags or microbeads. Educate others. Share facts. Show this video to people. Encourage schools and communities to reduce plastic use. Tell your friends and family the effects and how you've done easy changes that they can do too. Avoid products with microplastics. Check your labels, make sure companies aren't greenwashing, do your research, and buy from sustainable brands. Support local communities and eco-friendly communities, um, packaging recycled materials, and look for certifications like Fair Trade and Plastic Neutral. Like I mentioned before, recycling properly is very important. These are all the recycling numbers of plastics to tell you what they make and how you can recycle them. So look at those next time you go to recycle something and learn how to properly recycle it. That's everything. Thanks so much for watching, and here's my works cited.